In this video, we're going to talk about relations, functions, how relations and functions are different, how you can tell if a graph shows a functional relationship by looking at it, and the topics of domain and range. That's our goal for this video. This is Chapter 3, Lesson 2, which is on relations and functions. A relation is how we move from one set of numbers to another. You often think about this as going from one problem to the answer, but it can really just be getting from one set of data to another. So here I've got what's called a mapping. This oval is containing a bunch of values. And this is all the inputs or the x values, and the set of all the inputs we call the domain. The domain right now is 1, 2, -3, 5, and 0. And they're mapping to all the outputs, and the set of all the outputs is called the range, or the y values. So right now 1 is going to 12, 2 is going to 20, -3 is going to 6, that's how you say this goes to. 5 goes to -4, and 0 goes to -4. We're finding some method to get from the inputs, or the domain, all the x values, to the outputs, which is the range and all the y values. A relation is some method of moving from the inputs to the outputs, from the domain to the range. And I'll give an example of this a little bit later so you can see it in a real-world context. There's 3 visual ways to show relations. One of them is through a mapping, which we just showed. -2 goes to 6, 1 goes to 4, 5 goes to -2. Another is with a table. -2 goes to 6, 1 goes to 4, 5 goes to -2, and then the last two are 3 goes to 3 and 0 goes to 3, which I didn't mention over here. Or a table, a graph. -2 goes to 6. This is the point -2, 6. This means the input was -2, the output was 6. -2 goes to 6. Here, this is the point 0, 3, so 0 goes to 3, 1 goes to 4, and 3 goes to 3, 5 went to -2. Input 5, output -2. Input 3, output 3. All 3 of these things are showing the same relation. They're showing some way of getting from an input to an output. Whatever those numbers represent doesn't really matter at this point. It's just that we're going from the input to the outputs through this relation. So here's a set of ordered pairs. Ordered pairs are coordinate points. They always come in the order x, y, in alphabetical order, meaning inputs and outputs. Take a second and express these ordered pairs in a mapping, a table, and a graph. And this is a good example where you should pause this and actually do it. Now that you've paused it and actually done it, -2 goes to 5, -3 goes to 4, 1 goes to 1. I'm going to draw these arrows now. 1 is also going to 4, and 4 is going to -2. So 1 goes to 2 different things, and 2 different things go to 4. This over here is all my inputs, it's the domain, and this over here is the set of all the outputs, it's the range. I can also do a table. -2 goes to 5, -3 goes to 4, 1 goes to 1, 1 goes to 4, and 4 goes to -2. Now ideally, we would list these in increasing order from least to greatest. So these would flip spots. If you ever can organize things in that fashion, please do so. The coordinate plane over here already organizes it for you. Like I can do -2, 5, -3, 4, 1, 1, 1, 4, and 4, -2. So the first number is your x value, the second number is your y value. So this means go to 4 on the x-axis, go to -2 on the y-axis, and that puts you here. 4, -2. I drew that arrow in a very poor spot. Okay, now domain and range is the collection or the set of all the inputs and all the outputs. Domain is the set of all x values. So I want to say that x, the domain, is everything that has an x value. Well, with this set of ordered pairs, and that's what these little wing brackets are telling me, I have a set. My x values are 5, 3, 6, 8, and 0. I'm going to list those in numerical order. So it's the set of numbers. I can draw that better. That's better. 0, 3, 5, 6, 8. That's the domain. The domain is just the set of all the x values. And I'm listing it with these wing brackets because we're not covering all the numbers in between. It's just the numbers 0, 3, 5, 6, 8, not everything in between. The range is the set of all y values. So that's going to be -2, 1, -6, -2, and 10. Now you heard -2 get listed twice. Don't write it twice. Just go from least to greatest. So I'm going to have -6, the set of all numbers from... I did it again. Why are you doing that, Grant? -6, -2, 1, and 10. Now you'll notice these sets aren't really matching up. I'm a mess over here with my wing brackets. These sets aren't matching up. I'm not saying 0 is going to -6 or 3 is going to -2 because those things aren't happening. So these sets aren't supposed to match. I'm just listing the x values and listing the y values. That's the domain and the range. So back here, the domain would be -2, -3, 1, and 4. I don't list 1 twice. The range would be 5, 4, 1, and -2. Domain is the inputs, range is the outputs. Okay, a function is a special kind of relation. A function is a relation where every input, every single x value, goes to exactly one output. Exactly one output. So in every member of the domain, all the inputs, each goes to only one output. The relation is called a function. So here, 5 goes to 21, 8 goes to 0, 2 goes to 21, -3 goes to 0, and 11 goes to -5. You'll notice that in the way it's set up right now, I guess 2 10 is also going to 8. Nothing is going to 1. That's okay. That's not a problem. That doesn't ruin the functionness. This is a function because each number here only points to one thing. If a number in the input points to more than one thing, you don't have a function. For example, this. Look at that magic I just did. Wow, your mind is blown right now. This is not a function. Why? Because 5 is going to 3 and to 5. 5 is going to 2 different things. So it's still a relation, it's just not a function. And not being a function isn't a bad thing, just like how not being a square isn't a bad thing if you're a rectangle. It's just how we're classifying things. It just gives us specific ways to talk about these things. A function is where each input goes to only one output. So, determine if these tables represent functions. Pause the video, look over each table, and identify which of these are functions and which of these are not functions. Good, thanks for doing that. Here, 5 goes to 2 and 5 goes to 4. This is not a function. Here, 5 goes to 2 and 5 goes to 2. That's not an issue. Okay, each input is only going to one output. It's okay that 5 goes to 2 twice. That doesn't break it. This is going to be a function because each input is only going to one output. Now here, 1 goes to 5 twice. That's not a problem. But 2 is going to -10 and 2 is going to 2. That makes it not a function. One input is going to 2 different outputs. Here, everything is pointing to 6. Still a function. Okay, that doesn't ruin its functionness. So when I talk about functions, think about this like it's a menu. Like you're going to go order a cheeseburger or something, and one burger costs $2.50. Well, if I order one burger, it'll cost $2.50. And if you order one burger, it'll cost $2.50. And if somebody else orders one burger, it'll cost $2.50. Every time somebody orders one burger, it costs $2.50. The input is 1, the output is $2.50. And if I order 2 burgers, and it costs $5, that's still a function. Like, a function means like it's working. Things aren't going to break. But if I go to this burger joint, and I order 3 burgers, and it costs $7.50, and you go to the burger joint, and you order 3 burgers, and it costs $8, well, now 3 is going to $7.50, and 3 is going to 8. And that makes no sense. There's no reason that should happen, unless like I'm getting a special deal, or I've got a coupon, and we can account for those things. But all things being equal, if I order 3 things and you order 3 things and they cost a different amount, something is wrong. Something is broken. Something is literally not functioning. But it doesn't matter if 2 different things cost the same. Like suppose that we go to the store, and in fact, talking about this one over here, we go to the $6 store, where everything is $6. You can buy item 1, it costs $6. I can buy item number 8, it costs $6. That's not a problem. Different things can cost the same amount. Just one thing can't have 2 different prices. I hope that makes sense. There's a quick and easy way to look at a graph and tell if it's a function. And that's if it passes the vertical line test. Vertical, of course, means up and down. Here's how this works. You draw a perfectly vertical line. And if you're lucky, you get to use a fancy computer that can slide it around and stuff. You draw a vertical line. If this vertical line hits a graph any time more than once, ever more than once, it's not a function. So first of all, one thing I want to make really clear. This grid, with all these grid lines on it, this coordinate plane, that is not the graph. We call it graph paper because it's the paper on which we graph, but this is called the coordinate plane or the grid or the Cartesian plane. The graph are the actual points that we put on. That's what it means when it says graph. So right now, this vertical line is hitting the graph once and not at all, and once and not hitting, hitting once, and here it hits twice. Since it hits twice, this is not a function. It's not passing the vertical line test because 3 is going to -1 and 3 is going to 2. One input has 2 different outputs. But this line over here is passing the vertical line test. There's no point where my vertical line hits this red graph more than once, so this is a function. Each input is going to only one output. So it's a nice visual way to look at a graph and see if you have a function. Now let's talk about this in kind of more practical terms again. These are points scored by different Blazers from a game a couple seasons ago now. So player 11 scored 5 points, and player 8 scored 7 points, and player 0 scored 34 points. And no player can score 2 different amounts of points, right? Player 0 can't score 34 points and score 18 points. And who is that? Is that McCollum or is that Lillard? I don't know. It's one of those Blazer players who had a good night. One player can't score 2 different amounts of points. For this to be a function, or for this to be a basketball game, it has to be a function where each player is scoring only one set of points. It's going to pass the vertical line test. Now, it's not like the score of the player, the number of the player affects their score. There's not going to be some like rule where I can say like multiply their number by 1/6 to get their score. These things don't depend on each other. So there's no rule to get from one to the other, but we can still list the domain and get it to the range through this mapping, through this relation, through this function. I think that takes care of our video for today. Go take your video quiz and start your homework. Thank you.